Alright, the first way we graphed that was just by plotting points. Now I want to show you another way. And this is a common way to graph these polar graphs as well. So if we graph this on a rectangular coordinate system, if I were graphing this, I would make a chart and I would say, well, my period is 360 degrees, so I'm going to pick my 5 points. And this one works out well because it goes to 360, and that's what we're going to do on our polar grid anyway. And then I know that the sine of 0 is 0 plus 1 is 1. The sine of 90 is 1 plus 1 is 2. Then we're back to 0 plus 1, negative 1 plus 1, which is 0, and then 0 plus 1 back to 1. Alright, so if I plotted this on a rectangular coordinate system, I know that I'm going up to 2. Right, so I've got 0, 1, 90 to 180 back to 1. Alright, so I know I've got the sine curve doing that. Alright, so this is another way to look at it. And I would look at each of these increments. So I would look to see what's going on from 0 to 90. I would look to see what was going on from 90 to 180. I would look to see what was going on from 180 to 270. And then I would look to see what was going on from 270 to 360. Alright, so if I translated this to a polar graph, if you'll notice here, from at 0, my angle is 0, going out to 1. At 90 degrees, I'm going up to 2. At 180, I'm back to 1. At 270, I go to 0. And then at 360, I'm back to 1. So really what this graph is doing is, if you look at each increment, we're going up to 2, and then back down to 1, and then we're going from 180 to 270, we're going to 0, and then from 270 to 360, we're going from 0 back to 1. Alright, so this is another way to think of it, and you notice that this graph looks like, I actually call them cartoids because they look like hearts, and this one looked too much like a heart. Probably it should have been a little bit more rounded. Alright, but either way, so the first graph I did was just by plotting points and getting enough points to connect the dots. This one I graphed the sine function on the rectangular coordinate system and then just looked at each increment. Now this one, like I said, worked out to be 360. But in general, you want to know what's going on all the way around, so 360. So if my period had been less than 360, you keep going. You keep doing that number until you get to 360 so you can see what your graph's doing. Careful when you're negatives. You have a negative radius, you're going in the opposite direction of that angle. Okay? I want to do one more of those just to make sure that... Alright, let's do some more of these polar graphs. Alright, so this is the approach that I would take with this. So I would look at this and I would go through the same process I would be if I were graphing this on a rectangular coordinate system. So I would think about my amplitude being 1. I would think about, if I were picking my 5 points, then I would do one cycle. So one period would be 360 divided by 4, which is 90 degrees. And we would have graphed one period of 90 degrees. Well, how would have I done that? I would have gone from 0 to 90. And I would have picked 5 points to graph one complete cycle. So to pick my points, I would have either gone middle, or I would have divided my period in 4 and that would have been my increments, which is exactly what I'm doing here. Now, this is all fine and good, and we would have taken that and we would have said cosine of 0 is 0 times 4, and so that's 1. And cosine of 22.5 times 4 would be the cosine of 90, which is 0. And then we established our pattern until we made a complete cycle, which is our period. Now, the difference between what I'm doing now is I want to figure out what's going on in this polar graph, so I'm not going to stop at 90. I'm going to go all the way to 360. Alright, now what's going to happen here? This is going to repeat itself in 360 degrees. It's going to repeat itself 4 times. So there's nothing that's going to change here except when I divide up my angles. I'm still using the increment of 22.5. Alright, so that's key. And if you're watching other videos and they'll tell you to take 4 pi and set it equal to pi over 2, and then you'll get, this is what you'll see, take whatever the argument is here and set that equal to 90 degrees or pi over 2, divide by 4, so you would use the increments of pi over 8, which is 22.5. It's the same thing. Alright, we're just thinking about this as we would have done the same thing if we were graphing this. We would have taken our period of 90 degrees and split it by 4, and we're getting the same increments here, except we're going all the way to 360 degrees. So, and this, just add 22.5 and get the rest of your theta values. And I'm looking at a piece of paper so I won't miss a value. So just trying to do it in my head. There's a lot of values, I know, but I want you to see what's going on before we start doing something else with it. Alright, so here we go. We've got all our angles in an increment of 22.5 all the way to 360. We already know that this is going to repeat, right? This is repeating 4 times. Alright, so this is just 1, 0, negative 1, 0, back to 1, 0, back to 1, 0, negative 1, 0, and back to 1. Alright, so here is what I'm looking at. Alright, so if I put this on a rectangular coordinate, I mean on a polar, I keep saying rectangular, I mean polar. When I put this on a polar graph, right, I'm taking this graph, and do you want to mark it off in 22.5? Alright, so here, we better do that. Alright, so there is 45 degrees, which means 22.5 is halfway. Alright, so there's my 22.5. Alright, so then I've got another one. Alright, so that's 67.5. Then I've got 90. And then I've got 112. I've got 135. Right, I've got 157. And I could keep going around all the way around, okay? Alright, I know this is 180. I know this is 360. Alright, now, remember when we graphed just our polar coordinates. Alright, so this is my distance, so 0 degrees, I'm going out, this is my direction, sorry, I'm going 0 degrees right here. I'm going out a distance of 1. So I'm going out to 1. Alright, then at 22.5 degrees, I'm going back to 0. Alright, at 45, so I'm going out to 1, back to 0. Alright? Alright, now 45 degrees, pay attention, this is what I want you to make sure. Remember that when our radius was negative, I go to my 45 degrees, and then I go in the opposite direction. So 45, I would go out to 1, and then I would go the opposite direction. So this is, I'm going out to 1 and back to 0. Okay? Out 1, because I went to 45 degrees, the opposite direction. I'm going back to 0. Alright, 90 degrees to 1, back to 0. Alright, 135. 135 is right there, going the opposite direction. So that's that. 180. Out to 1, back to 0. Alright, at 225, which is right there, I'm going negative 1, so I'm going the opposite way. So here I'm 45, back to 1. At 270, I'm at 1. Alright, and at 305, I am negative 1. Where's 305? Alright, so there is 305. Cross from that to 1. And then at 360, I am back where I started from. Alright, so this graph of cosine of 4 theta looks like a petal graph because it's got all these petals. And all I did was follow this around. So I went out to 1 with my distance and then back to 0. So I followed that around. And just be careful when you're negatives. You have a negative radius, you're going in the opposite direction of that angle. Okay? I want to do one more of those just to make sure that